Hey folks, sorry about the delay there. Just getting things up and running a little bit. Um, so, welcome to Study Hall. So I'm gonna just start, I think, just sort of going over this at the beginning of every study hall. So apologies if you've heard this before, if this is repeat news, but just a quick reminder, the purpose of Study Hall is to give you all a forum to ask questions in this setting, and we can all discuss the questions together. Which, I mean, for now, for streaming sake, is going to take the form of me just basically answering the questions on stream. I will try to do so in a way that's tailored to any specific, point of understanding that you need. So if you have a question on Learn or from Code Wars or really anywhere, if it's within the scope of what we would go over in Premium Prep on Learn, then I will be happy to take it. All right, let me just get this started here. Cool, and you can submit questions on under the as a reply to the message that I posted in the DS Basic Prep Slack channel. Galvanize. If you're coming here from YouTube, we do have comments disabled. So, or not comments. What am I thinking? You know what I'm saying. Cool. Cool. So I'm thinking we have some. I'm still kind of debating whether to do. Yeah, let's just do the stuff from Learn. I'm thinking at some point that I want to go through and do some Code Wars problems, as well as work through stuff in Learn, just to kind of show how I go about that. And I do want to do a Code Wars specific stream at some point that's more oriented around that. So, all right. Cool. So last time we covered a bit on lists, and we're going to be diving deeper into lists with this section. So let's see what the goals for this section in Learn are. Manipulating lists overview. At the end of this, we want you to be able to modify values within a list, append and extend a list as well. Append to and extend a list. Cool. So let's talk about copying. In order to understand why copying is useful and what it is, we need to understand what mutability is. And I've covered this topic in some detail on stream as well as in Premium Prep, but it's worth talking about again because it's kind of it can be kind of a funny concept. So mutability means the ability for a type object, a list being a type object, an integer being a type object, right? So the ability for a type object to change its value internally, right? So I think this often gets confused with updating the value of a variable. So just to give some context here, Python has multiple types. There are mutable types that have the ability to be altered internally, like they can alter themselves, kind of. And then there are immutable types which don't have that ability, right? So just to do some compare and contrast, for example, like an integer is an immutable type. A string is an immutable type. These are not mutable. A list, however, is mutable. Whatever, we'll do something like that. So what do I mean by this? Now I do need to save this into a variable in order to showcase this, otherwise nothing's going to happen with this. But if I print this list out, obviously we're just going to get the list that was in it. But I can use this tool that is built into lists, which is a method called append. We can say list. Probably you all have seen append by now, but if you haven't, append, and we'll append 55 to this list. So now if I run my code again, I'll have the number 55 tacked on or appended to the end of the list, right? So what happened here is append is a list method, right, that allows us to change the value of this list, right? And this is different than the way that an integer, for example, would change. If I say num equals 5, and then I do like num equals 6, this is a different kind of thing, right? Like I'm not altering the integer 5 to turn it into the integer 6. I'm taking this pointer called num, and I'm taking it from being pointed at 5 to pointing at 6. So what I'm doing here on these two lines is altering the variable rather than the value held within the variable. There is a significance to this, and I'll demonstrate that in a minute. But let's just look at proving this for now. There's a way that we can prove this. So there's a built-in function called id. We need to print it out. If I print the id of num here when it's 5, and then we print the id of num when it's 6, it's going to give me an internally generated id that will tell me, the ID of that object in my program. And if I run this multiple times, you can see we're going to get a different result every time. It's just going to assign a new ID. These IDs are arbitrary; they're not going to persist from one run to the next. But what will be the same is that, well, I say the same. A similarity that will persist is that these two will always be different, right? I'm pretty sure if I do this, oops. If I assign it back to 5, I think I should get the same ID again as the original. Yeah, I do, right? So if we look at this, I'm not going to read out the whole number, but if you look at the right-hand side of the number, this one ends in 1248, then 1280, and then back to 1248 again. And this mimics num being 5, num being 6, and then num being 5 again, right? So this shows us that this is the ID of the object in memory, right? This is the ID of the actual value, the data type. Not, that ID doesn't go with the variable name, it goes with the value that variable holds, is what I'm trying to get at here, right? So lists have a different behavior around this when we use append like this to alter a list. So I'll print the ID of my list. Here, and then I'll print it again after we append. Okay, so we know that the value of the list changes from line 10 to line 12, right? Because we do this append, and that changes the value of that list. If we look at the ID, of these two lists, we can see that they both end, well, they both have all the same numbers, right? So these IDs are the same. If you look here, they both end in 8, 1, 2, 8. So these IDs are the same. So this shows us that we didn't point it at a different list, right? In the integer example, what we did is we took the pointer called num and we pointed it at a different object. We pointed it at a different integer, right? In this case, what we did is we took a list and we altered that same list, which is different than pointing the variable to a different list, right? The variable still points at the same list. The list still has the same ID in memory. It's just that even still having the same ID, its value changed, right? So it's the same list according to Python, according to the identity that Python gives it. It's the same list, but its value has been altered in some way. Okay, so this proves and sort of just demonstrates that it's true that lists and numbers have different behavior around their IDs. This behavior is basically proof of mutability, right? So mutability, again, means the ability for the type itself to change, right? And we can prove that the type object, this list object, changed after we appended because we know the value changed, right? But the identity stayed the same. So since the ID stayed the same, it's the same list, it just changed, right? So that behavior is called mutable. The behavior where if we change the pointer, to change the value, then we're not altering the type object itself. Cool. So let's look at an example of why this is important. And actually, let's look at tuples and lists. So we'll do tup equals a tuple, and oh, actually, I can just do this. List equals a list. So let's say we'll just do like identical information for these two. We'll say 5, 3. Oh, I don't know. 5, 3, 9. Cool. So let's say I want to write a function that takes these in and returns whatever the collection, the original collection, followed by the squares of the original numbers, right? So we'll say 5, 3, 8 should turn into, our function should return 5, 3, 8 with 5 squared is 25, 3 squared is 9, and 8 squared is 64, if I'm not mistaken. Yeah. Cool. So there's a way that I can build this function that is kind of weird. So we'll say print let's do square sequence. We'll call it square sec. And we'll take in list. Actually, let me call this my list. My top and my list. Okay. So we'll say def square sequence takes in sequence, and we'll do a list version and a tuple version. We'll do two separate functions here. Actually, instead of calling this sec, I'll just name them different functions. So we'll call this square list, and we'll do that one for list, and we'll do another one for tuple. Tup. Okay, and we'll just comment that out for now and come back to that. Okay, so let's do the list version. So it might be easy to say for L, we'll call it num in list. We'll say list dot append. This is gonna actually give me a problem. List dot append. Num squared. Okay. And we'll return num. Nope, excuse me, we'll return list, which is our input. So this is actually, I just realized this is going to give me an error. When I thought of this, I didn't realize it was going to give me this error, but it's going to say list it changed size during iteration. Oh, interesting. Huh. Okay, yeah. I have this essentially in an infinite loop, which this is pretty interesting because I'm going through this for loop. This is actually an odd example of how you can get a for loop into an infinite loop accidentally. But this for loop is going through this list object, and since I'm altering that object itself, since I'm adding to it, it just keeps going through it, right? Like it's just going to keep going to the next number infinitely. So yeah, that's a bit of a problem. We might do something like if len list is greater than 50. Let's do that. We're going to get a lot of numbers in here. Then we'll break. So let's try that. Cool. Okay, so this gives me, I mean, that's a whole lot. Let's pare that down to like, I think even just like 12 is going to be a lot. It's going to be, we're going to get some pretty large numbers. Oh, okay. Yeah, that's more manageable. Good. Okay, so check this out. Couple problems with this, right? Since append alters the type directly, this for loop has lost its exit condition unless I like tell it when to stop with this break, right? Because that for loop is just going to keep going on to the next item, and every time I go through the loop, I add an item. So I add an item, and then it goes to the next item, and then I add an item, and it goes to the next. So it's just feeding on itself. So that's one problem, right? So that's sort of undesirable behavior. Another problem is that, well, check this out. We take in a list. Now let's look at our original list. And I'll just comment that out for now. We'll just focus on this. So here's our original list. Let's even just call it my original list. I'll do that. Okay. So here's our data, our original data. We pass that data to our function. Our function does this weird loopy thing. It loops over the input, it alters the input, and it returns the input, right? So if I print my original list, it actually altered this list. So this function actually literally changes this list. I'm tempted to like reserve the possibility that there is a use case for this kind of behavior, although in my opinion I consider this an anti-pattern. When you write a function, the rule of thumb should be that your function does not alter that it doesn't alter its inputs, right? This function mutates its input, right, which is a bad pattern, in my opinion. You may encounter somebody that disagrees with me on that. There may be legitimate and valid cases to do this. I'll tell you, I have never encountered one. I've never looked at a function that mutates its inputs, and I've seen that out in the wild. I've never looked at that and thought, well, I guess it has to be that way. I've never looked at that and been able to actually find a justification in practice for this kind of behavior, which is kind of funny because Python allows you to do it. I think most languages that I've learned do allow this kind of behavior, which is a little bit weird. So even though it's possible, doesn't mean you should do it. In this case, this is sort of a disaster because you have this data, and by passing it to this function, you don't you want to be able to rely on the function not altering the thing that you pass to it. That can just make it really hard to predict how your data is being altered, right? Cool. Okay, I think I've made that point. So one thing we can do in this case is we can reappropriate this pointer called LST, and we can just say list equals list.copy. This or something like it is best practice. You don't need to necessarily reappropriate this, right? To be clear, you might look at this and say, well, isn't this going to mutate list? And it's not. What it's going to do is it's just going to take this pointer, LST pointer, and it's going to point it at a copy of itself. But that doesn't alter the original. It just reassigns this pointer parameter, right? So if I do this, cool. So if I do this, this is going to actually alter the list in the way that I wanted it to, right? So notice that I mutate this list internally in the function, but my original list in the global scope here was unchanged, and we can see we got the original list when we printed that out. So this function now doesn't mutate its inputs, but if we look at this, it also still doesn't do what I initially set out to have it do, right? So we can use copy in another way too. So let's do this. Let's say copy or list copy equals list dot copy, and then we'll iterate through list copy. And then let's also do list out, and this will be our output. This will be our actual accumulator, and we'll say equals list dot copy. So we'll also copy the list into the list output. Now I can get rid of this break. We'll just comment that out for now, and we will alter list out. Oh, I actually don't need to do this first copy. So we'll just iterate directly through list here. Cool. Oh, and I do see we have a question. I'm just going to wrap this up real quick, and I will get to your question. Cool. All right, cool. So if you look, I got rid of the break. I don't need the break anymore. I commented that out, so that's no longer active. I'm iterating through the original input list, my original list here, right? And then I'm making a copy of the list, and I'm using that as my basis to append onto, right? So this appends as if it were appending to the original list, but it's appending to a copy. And then the nice thing about the behavior of this function is that it takes in the list, it returns a copy of the list in the version that I expect that function to produce, but it also does not alter my original list, right? And what allows me to do that is this .copy method. So copy is useful for like ensuring that you only mutate your types when you want to. Excuse me. Okay. Cool. Comment that out. And let's turn our attention to this question. Sorry to keep you waiting, by the way. Get a few of these. All right. Okay, cool. So the question for this problem is, could I get assistance with third challenge in string methods / functions? Looks like we're on split. Yeah. Okay. And they also provide their code. The third challenge. So, okay, maybe I'm not quite sure I have the right link here. We'll go through and we'll see if the third challenge matches this. Split on this, split on this. Okay, good. Oh, I'm sorry. Yes, I I understand now. Yep, there we go. That's just me being dyslexic again. Cool. So write a function called split on this. This function takes arguments. First, it takes a string called split me. Second, it takes a letter called splitter. This function should return a list that is split on every occurrence of that letter. If that letter is not in the string, the function should return cannot split on that letter. Okay, cool. Cool. All right, so first step, I'm going to write some tests. Print split on this. We'll take a string. So let's say the string is hello there. I'm not a banana. Gosh. Okay. So we've got these periods in here. So let's split on those periods. We'll say split on that. And what we expect from this is a list of hello there. We will omit the periods. Oh yeah, actually there will be a space there. And we'll omit this period as well. Okay, cool. Let's do another test. I'll just leave that as a comment. So let's do another test here. So let's say we'll split on exclamation points, and this one should return cannot split on that letter. Okay. Cool, let's run this. Interesting. Okay, so it looks like it's returning a list object. So it's actually returning or a type specifier is what it returns. I see this here, list. This is the name of a built-in function, and it's also a type specifier keyword in Python. So you can return a type specifier, like if I were going to return string or something, str, that'll say class string. If I say int, it'll say class int, right? So these are the names that Python recognizes for some of its built-in types, right? list, like this, will return a list. There's also a function by the same name as there is for str and int as well. Cool. So we could do this. And this will just return us an empty list in both cases. Cool. All right, I'm a little confused as to why splitter. So the second argument that I passed for splitter in the second example, in this case, is not in the string. So we should be getting cannot split on this letter. This is the reason I go to this first is this is an edge case, and in general, like you handle your edge cases as soon as possible. You handle them by convention whenever you can. You handle them at the top of your function. You can't always do that, but if you can pop them in the top of your function. We'll do that in a second here. But I do see it being handled here actually. So it says so for splitter in. Okay, I get it. This identifier is being initialized twice. So we have splitter as a parameter and splitter as an identifier being initialized in this for loop. So when we write this function head, we call this parameter, we call it splitter. This is an identifier that exists that holds whatever that data is. And then when we go through the loop, we have the opportunity again to or we have to give an identifier to every element in the iterable object that we pass into the for loop, right? So strings are iterable. We can iterate through the characters, which is what we want to do in this case. And we can use, so this is saying for splitter in split me. If I print, here we'll just comment that out for now. So if I print splitter, cool. So we'll see that this is a test. What? Oh, okay. I see this as well, right? So split me is being overwritten with a new input, right? So this is a common mistake to make. It's important to remember that when you're defining a function, you don't supply data to its inputs while you're defining it. So this to me reads as an attempt to give split me a value, which is very sensible. Obviously, if it doesn't have a value, then what is it, right? So I don't know how I missed that. I'm feeling extra dyslexic or something. So this is an attempt to give split me a value so we can have something to run through. But the unfortunate side effect of doing it this way is it overrides whatever the value passed was, right? So it just, again, it takes this pointer and it just points it at a different string. But the way we give this a value to work with is when we call the function. So that's how we supply actual values to our inputs, is when we call the function, not when we define it. So one way to remember this is during the definition, while you're defining the function, you're defining a generic process. When you call it, you're calling the generic process with specific inputs, right? So these are specific. This is specific in the sense that hello there, I am not a banana is a specific string value, right? These are specific values, right? So we can treat splitter like a variable that we don't know the we can treat split me and splitter like variables that we don't yet know the values of, but we can assume the types of. So we can assume split me and splitter are both going to be strings, right? So I'm just going to get rid of that for now. Cool. Okay. So if I run this for splitter and split me, cool. We're going to get hello there, right? So that tells you that splitter represents every character in the string. In general, when I run through the characters of a string, my preference is to just call each character a character. I mean, that sounds like a tautology, I guess, but in most cases, it's reasonable to just use a generic name because these are just arbitrary characters. We don't necessarily know what they are. Cool. Okay, so what occurs to me is we could say if splitter not in split me. So this is definitely an edge case, and this will work right up top, right? So we can say if splitter is not in split me, then we know we don't need to do anything else. We can just return cannot split on this letter, and I'm just going to pass here, comment these out, and run it real quick. Oh, you got that data from one of your error messages. Yeah, yeah. So um, the person who asked the question just put that in the Slack. They said they got that original, this is a test data for SplitMe in one of their error messages. The reason for that is in Learn we have formal tests written that are more complicated than this print line, but this print line sort of is an analogy to that. And it's passing in this is a test like that. That's what's happening there in our internal tests. Cool. All right, so it looks like the second one is, I'll just delete this real quick. It looks like the second one is getting the correct result, so we're handling that edge case, so I'm not going to worry about that in the future. On to the remainder of our code. Quick side note on this. If you have a function with a for loop in it, and the for loop has an if, has a conditional chain with an if and any amount of elifs that is followed by an else, right? In this case, we just have an if and an else. If you have a conditional chain in your loop, and each body of the body of each of the conditions has a return in it, then what that means is the loop is only ever going to execute one time, right? This loop has no choice but to resolve to one of these returns. You know, like it's going to go through here, and if this first condition isn't true, then it's going to run the code in this else, which is a return. Since returning from a function stops any further code execution inside that function, it stops the loop as well, right? So we're not actually going to get the full loopage out of this. So this is something to watch out for. I see a number of people making this mistake, and it's fine, it's understandable. And I think there's something, and I remember going through actually exactly the same thing. Like I said, this is a really common thing to do. But I remember thinking, oh, well, whenever I have an if, I should always have an else. And that really isn't the case. You don't always need an else. Often you will use an else, but you don't always need one. And in certain cases, like it's fine to have a condition inside a loop that has a return in it. I mean, there are certain cases where that's really useful to do, but it can't be like, it can't be imminent, right? If it's imminent, then you're not going to get any loopage, right? So this is an imminent return. Like it's going to return from one of these two bodies no matter what. So, cool. So I think we do need a condition here. I'll just take our edge case back up here. So we'll say if something, then I'm actually I think I'm gonna approach this like an accumulation pattern problem. So we'll do out list, again, be an empty list. So we'll say if ch is equal to splitter, then we will So this is the interesting thing. We want to append all the characters before splitter from the last splitter character to the current splitter character, not including the splitter characters, into our out list. So we're going to do out list dot append. We'll get to what we're going to append here in a second. I'm just going to return out list. And I'm just going to run this a bunch until like I sort of adjust it into what I want to be seeing here. Okay, so what occurs to me to do is to slice split me according to the index of the current characters, right? So what I need is the index of all these characters, so I'm going to do enumerate. We'll do IDX for IDX and character in enumerate list. And I'm also going to make, since I need to know the index of each splitter individually, I'm going to make a variable called last splitter index equals, I'm going to start it at 0. Okay, so what I want to do is split, or excuse me, slice the list from last splitter index, we'll start there, to IDX. I think I will probably need to adjust that. Then after we use last splitter index, we're going to update it and we're going to say last splitter index equals IDX. And then that will persist to the next one. So I have no idea. I think this is probably not going to work the first time, but we'll just see where we're at. I'm running the code to see where I'm at. Cool. So I get hello there. And then, oops. Oh, that's really interesting. Huh, okay, cool. So I get hello there, and then period space, I am not a banana. Okay, so that tells me I actually, want to adjust this index just a little bit, right? So I want to push that because I'm appending this period here, and I don't quite want to be doing that. And it also occurs to me that this might cause a problem if it doesn't end in a splitter character, and I think it will cause a problem. So if I have a list that, or an input string that doesn't end in a splitter character, it's not going to actually append it. So I need to update that. So we'll say if ch is equal to splitter, or IDX is equal to len of split me minus 1, which will be true when we're at the last index of the list. So we'll just see if that gets that character in there. Okay, cool. I'm starting to think, just for the sake of simplicity, I'm just actually going to do this as a separate thing. Okay. So we'll see, we'll just handle these separately. And we'll say, I think we don't need to update that if we're on the last one. In this case, we can just go to last splitter index all the way to the end. And I'm trying to rectify this. The A on the last A in banana got cut off there. Invalid syntax if, oh, this is, I forgot a colon there. Cool. All right. Excellent. So we still got a couple problems. I think this first problem is that I want to get rid of this prepended period. So I'm just going to adjust the last splitter index, which is where this is starting. I'm just going to push it up by 1 after the first time. We'll just push it up by 1 and we'll see if that works. Okay, so I get my space. I'm not a banana. And then I am getting this empty string appended. And that's under an interesting case. So that's if, yeah. Huh. I think I actually want to do and not this other condition. We'll do that. We'll just try that. See if that does it. Okay. That does get me closer. However, I get this period on the end here. So I want to make sure that that doesn't get added in. I could just handle it with a condition explicitly. I think I'll just do that. We'll just say for the last character, if... Actually, is this working as an elif? That's what I want to know, elif. I think this will behave the same. Okay, good. So if the character at the last index is equal to splitter, we will append up to IDX. I think we can do that. I think that'll do it. Ugh. Oh. This one we will have an else. Okay, we'll see. Yay. Cool. So that looks good. For those of you watching who see the easier way of doing this, I just wanted to demonstrate the manual way. We'll see. I'm not sure this is going to work. If this doesn't work, I'm just going to go for the easier way of accomplishing this. Oh, it works. Hooray. Okay. So this is sort of manual code for this. Unless it's saying specifically not to use the split method. I mean, I presume it actually wants us to use the split method. So I think we can just return, we'll do the same edge case condition here. And then we'll say return split me dot split splitter. We'll try that too. Correct. Cool. So I imagine this lesson is actually alluding, actually wanting you to write this second code, which, as you can see, if you know the split method, is just much, much easier, right? But I just wanted to chase this out to show you could solve it without the split method, but it's kind of a long road. This is a bit much. There's a lot going on here. This is a lot more manageable. Hopefully that is clear. The difference here is this split method right here. So let's just take a quick look at what that does. That's really interesting. It in learn I worked to get this function to not do this very thing, but evidently either way is acceptable. That's interesting. Cool. Or learn is not testing that condition, which it may not be. Okay, so the split method just takes you call it on a string. So it's a string method. So you say string.split, and then you give it a character to split on, and it will return a list. So you call it on a string, but it gives back a list of all the substrings as their own elements, separated by whatever the splitter character that you specified is. So if I do, let's just pop into a terminal to do this really quick. If I do dot split on periods, then I'm going to get this list. Hello there, I'm a banana. And notice that all the periods are omitted, and all of the places where there were periods are the delimiters for each new element in the output list that split produces. Cool. Nice. That was a fun question. I rather enjoyed it. Cool. All right. Let me know if that was helpful for you to the question asker, or if you have any follow-up questions or anything else. We'll leave it there. Cool. Oh yeah, sure thing. Yeah, I like doing it. I like kind of doing it the long way. There's something to be said. I mean, just as a quick aside here, like there's something to be said for like, if you look at this, this is a simple set of tools, and it just shows you kind of how powerful they are, right? Like, I'm using enumerate. I could even get rid of enumerate and do like a manual indexing incrementer, although I don't want to, because enumerate's really handy. But this is just basic for loops, basic conditions. I'm using an and a not, which makes this condition a little bit heavy, but it just shows you, like, if you have a good mastery over the basics, you can kind of do whatever you want. Obviously, this is just a small function like split, but there can get way more nuanced than that. But yeah, cool. Let's see. Where to go next? Do I go back to copying? Yeah, we can go back to copying. Well, I feel like I kind of made my point with copying. About, let's take back to this example. Also, to be clear here, I'm going back to copying because we're done with this question, and I don't see another question in Slack yet. So, feel free to pop another question in, and I'll stop and take it. Cool. Yeah, back to this copying. This is, I think that the takeaway here is you want to write functions that don't mutate their inputs, because that can make your data really difficult to deal with and hard to predict. I was going to show a tuple example of this, but I think it's not really that necessary. the short story here is if you're working with a list, just use copy and, excuse me, just use the copy method and then alter a copy of that list if you want to alter a copy of that list. Yeah. And also, always work in a way where you're testing your code, like what I have selected here. I'm referring to these as tests. These are tests in the sense that they're helping me like test my code and run it as I'm working on it. If you're familiar at all with formal test-driven development, then these are obviously not formal tests, but they are. I think it captures the idea of what a test is supposed to do, nonetheless. So they're tests in that sense. So as you're working, I can't overstress the importance and just the extreme utility of writing at least one test. If you ever get stumped, you can just use it as an opportunity to write more tests and have more tests to test your code against, right? And a test, usually, I don't always do this, but usually you want to, ahead of time, you want to sit down and think, okay, so for a given input, what should my output of this function be? Things like that. In this case, I also am printing off this my original list variable to ensure that it hasn't been altered, right? So I want to see it in its original form, not in an altered form like the function returns. So yeah, having tests is a great way to get things done. Cool. All right, let's go through this stuff on copying. So what's the point? What is this? What is it telling us it wants us to know? So create distinct copies of a list. Utilize list copying within functions that take a list as a parameter, which is what I just showed. Oh, this is showing. This is showing what's called a shallow copy. I forgot to actually mention this. This is sometimes referred to as a deep copy when you make when you use the .copy method. Sometimes called a deep copy. A deep copy makes its own independent object, whereas a shallow copy just points another identifier name points another variable name at it, which is kind of a weird thing. Let me show that actually. We'll just do this. Sort of a similar thing. We can say list A equals this list, and we'll say list B equals list A. Right? You might think, oh, that's a copy. I mean, if it were a variable, or it is a variable. If it were an integer, then sure, yeah, that's a copy. But if I print the ID of list A and list B, we're going to see the same ID. Oops. Excuse me. I'm about to sneeze. Like right on the edge of sneezing. Okay, I can't tell if I'm about to sneeze anymore. Apologies. Let me just take care of this. Sorry about that. I just had to blow my nose real quick. I didn't want to do that on stream. Cool. So if we print these IDs, we can look and we can see that these IDs are the same. If I say list list B dot append. I mean, they're the same IDs, so hopefully you should be able to infer, given that the IDs prove that they are literally the same object. You know, it's an object with two names. It's the one object with two names. So if I append to B, what's going to happen to A, right? So if I say list B dot append hello, and I print list A, right? So I appended to list B, but I'm printing list A. Did it change or not? You know, you can think about that. And we printed list A, and we get the modification that we did to list B, right? Hopefully it goes without saying that list B is going to have the same modification too. These are literally two names, two variables that point to the exact same object in memory. Exact same object, right? So say I don't want this behavior, which you probably don't. Let me go out on a limb here and say that this is never a good idea. Excuse me, that having two names for the same object is never really what you want. I don't know, maybe somebody has a case against that, but I can't think of a good reason to do that. So let's say I want to actually make a copy, a deep copy, a proper copy, a useful copy. So I say list B equals list A dot copy. We'll print the IDs. We see the IDs are different. We append to B. We print A and B, the values of A and B. And we can see that they have different contents, right? B now contains the modification that we made to it, whereas A stayed the same. So that's something. Another thing to watch out for, and another thing that copy is helpful with. Cool. Changing an element in the list. This is called item assignment. So let's take another list here. So let's just call this list. And then we'll say, we'll just pare this down a little bit. So I've got 5, 3, and 8, and we'll say list sub 2, that'll be that 8, equals, let's just do something hello. Something nice and conspicuous. Oh, I gotta print it, print list. Like, why didn't it print anything? Because it didn't print anything. Cool. So you can see I changed that in there. And I could reassign any item in here. Python refers to this behavior as item assignment. So I can specify an item in the list and assign to that item directly by saying list and then indexing into the location, the index location that I want to modify, and then modifying that with the new value that I want. There, cool. And just to prove this, we can say list sub 1, but we can assign to any of these. I think that's obvious, but yeah. Cool. Okay. Copy. Dolphin, that's just the inverse of what we just went over. Okay, so this is gonna take in a list of nums, add one to each. So presumably it's gonna, we have 1, 2, 3, 4, 5. We're gonna get 2, 3, 4, 5, 6. Excuse me. This is gonna make a new list called nums, and we'll do for index in range the length of the num, and we will mutate the nums variable with this item assignment pattern according to the index, and then just return nums. So we're mutating, we create a deep copy of the list, the original input list called list of nums. We create a deep copy of that, and then we alter that deep copy with this item assignment in here. List subindex, or excuse me, num subindex plus equals 1, and then return nums. Cool. I don't think we need to run that. This is a good point. There are other ways. There are other things that you can do that will cause a copy to happen. So anytime you slice a list, we'll do this actually. So anytime you slice a list, I'll just do this. We can excuse me. Anytime we slice a list, we're going to get, that slice is going to have its own ID. So if I say list slice equals, we'll just call this list. List slice equals, let's say we want this 9021. We'll say list sub 1, 2, this will be 1, 2, 3, 4, so that'll be 5. We'll go up to 5. Oh, I got a print. We'll say print list slice. Cool. 9021. Good. So if I get the ID of list and the ID of list slice, we will see that they are different IDs, right? So hopefully this shows that this that slicing a list, the slice is its own object. It's not a portion of the same object and therefore the same object. It's its own object. It is literally its own object. So what this means, weirdly, is that I can say new, we'll call this list copy, equals, I'll actually do this in its own section here. Do this, da-da-da. We'll call this list copy equals list, and I always just call this a full slice. Like it's a slice, but you start at the beginning, you end at the end, and you go in steps of +1, which is all the assumptions that are made when you leave everything blank. So you can call that a full slice because it's a slice of the whole entirety of the list. The funny thing is, it's a de facto copy. List, or here, let's print list followed by its ID. And we'll do the same with list copy. Cool, so you can see each list has its own excuse me, each list has the same values, but they each have different IDs. Cool. Yeah, and sorry. by having different IDs, hopefully that demonstrates that that's a copy. Cool. All right. So let's do this challenge. So write a function called return a list. Da da da. Write a function called return a list. That takes a list as an argument. The function should simply return a copy of that list. Okay, cool. So we'll just do this. Def takes in a list, return a list dot copy. This will work. So that's going to work. This will also work if I do full slice. Let's just do it the long way. Out list equals empty list for element in list out list dot append element return out list. Right, so I just append every element. Since out list is just being created as an empty list, we can just iterate through for every element and append every element into out list with that for loop, and this will also work. Bit roundabout, you know, kind of a lot of code to just do what you could do with a copy or a full slice, but you can do it that way. It works, you know. Is that it? Did I skip some? No, that's it. Cool. All right. Mutability and modifying list values. So by the end of this lesson, we want you to be able to describe mutability in terms of lists and modify values in a list using indexing. Isn't that what we just talked about? I guess we kind of saw that. Item assignment. That's what this is. Yeah, this is just talking about ID and item assignment, which we already explored. I'm just going to jump right into the challenges. Cool, there's 3. So write a function called verify IDs. Let's just do that. Oh, well, I'll do it the other way. Write a function called verify IDs. Oops. Why? Why Python? Why? Really? Weird. Okay. This function takes 2 lists as arguments. Return a Boolean whether the 2 lists have the same ID. Okay. So we'll say def verify IDs takes in list 1, list 2, and we'll put in return. Let's do some tests. Print verify IDs, and we'll do list 1, 2, 3, list 1, comma 2, comma 3. And it's a Boolean, so we can just say list1 equal to list2, right? This resolves as a Boolean value. List1 equals list2. I mean, think about it. You know, is A equal to B is a true or false statement, right? So that's a Boolean. We can just take it from there. Cool. So these two lists have the same ID. If I do let's try that. That's really interesting. Oh, I'm being silly. This is because we want to see if the IDs are the same, and that's not what this is testing for. We actually have to do the ID there. I'm like, that's not really the result I was expecting, but okay. All right, cool. So we'll do list like this. And then we'll say list here. And then we'll say list 1 and list 2. And we'll do list 1 and list 2. Okay, so that's all false. And then let's do another one. We'll say list 1, list 2 equals list 1. Cool, so that's true. And here's another one that I expect to be true. LST, cool. So you can see I'm just writing a bunch of tests. Like at this phase, it just makes testing like really easy, you know, like I can just think of various inputs and just throw them together and have a few tests. So we wound up with 5 tests for this. Not that it really matters, but helps me get a sense of whether I've done it correctly. Cool. I believe that's exactly the same code, is it? Probably used. Yeah, same code, different names. All right, write a function called modify third element, blah, blah, blah. Write a function called modified third element. Okay. That takes 2 arguments. The first argument is a list of at least length 3. That takes 2 arguments. The first argument is a list that is at least length 3. The second argument is the element that will replace the item in the third position. Okay. So we'll say modify element. We'll take in a list of, what am I doing? Yeah, let's do this. My list equals list. No, what am I doing? I think I want to write it here. List and L. Okay, good. My list equals, let's do a list of at least length 3. Let's do my L. Cool. And we'll say good. All right. So, oh, my element. What do I want my element to be? So this should give me, what is this? Expect equals 3, 2, high. Just a variation on how I usually test things, but we can just print that out here. Cool. Let's just see what happens. Obviously nothing's going to happen, but we're just checking, making sure the syntax is good. Okay, so we get none. Our function returns none, which is what we expect. And our expect is 3, 2, and high, and that's what we want this function to do. Okay, so I can say list sub 2 equals L return list. Cool. And then if we print my list, think about what the value. So we take my list, we pass it into the function, we say list sub 2 equals element. What's going to happen to my list? Is it going to be mutated or not? Right. Let's try this out. Let's even do another test, and we'll just do 7. We'll do a list longer than 3, and we'll just have 7 there. Cool. Okay. So that's not altering our original input list. Oh no, excuse me. It I'm sorry. It is altering our original input list. You can see these lines with one list on it are our original inputs, and they do have high there, right? So I think what I want to do is list equals list full slice. I'm going to just do full slice. Let's just call it out list. And we'll say boom, boom, out list. Good. That doesn't mutate our original input. I don't know if this wants us to do that or not. Okay, so it takes 2 arguments. The first is a list of length 3 or more. The second argument is the element that will replace this third position item. The function will return the modified list. Okay, so it returns the modified list. Be sure to follow best practices taught in the previous lesson by not modifying the input list as a parameter, but rather a copy of the list. So it wants us to do this copy of the list as well. Cool. So let's just try this out, see if Learn likes it. Correct. Yay, that worked. It occurs to me that we could just totally slice this like list sub. I want to start at the beginning. Actually, I'm just going to do this. Plus, we'll concatenate it all together. L plus. Yeah, okay. So in this case, I think we want to go up to 3, and then we want to go to, we want to start at 2. Is that right? I don't know. I feel like maybe that's not going to be right. I want to start at 1. Nope. 3. That's not going to be right. That's going to be list index out of range. Oh. This needs to be 2. So that gives us 3 too high, and we expect 3 too high. And it doesn't alter our original. And then the next one gives us 3 too high 7. We expect 3 too high 7, so that should work. Okay, so here's a little one-liner version. I think this will work if my tests are testing for the same things, which I don't know. Cool, that works too. Good. Cool, I think this is a good place to wrap up for now. I hope everybody enjoyed stream today. Let me know how it was. If the signal fidelity was good or if it was kind of funky. I definitely want to hear your comments. If you liked the video and you're watching on YouTube, obviously you're watching on YouTube. If you liked the video, feel free to like it. If you didn't, I guess dislike it. And comment, subscribe, all that. Hit me up on Slack and let me know what you thought. Share your ideas if you have ideas for how we can improve these. And yeah, next time we'll be streaming I'll be streaming on Monday. So yeah, stay tuned and look forward to it. Have a great rest of your evening. Bye-bye.